Okay, welcome to tutorial 10. In this video, we're going to introduce the idea of general equilibrium. To do this, we're going to build a model, what we call the Edgeworth box. It's going to build on, first, our notion of the consumer's problem, but we're going to do it with more than one consumer. So to do this sort of concisely, we have a model, what we call the Edgeworth box. And once we build the Edgeworth box concept, we'll introduce competitive exchange, which essentially just moves us from a barter economy to an economy with prices. Once we're done building up prices, we will go on to talk about how production plays a role in our competitive equilibrium, our general equilibrium. And to do this, we'll introduce the production possibility frontier, which you might be familiar with from your intro microeconomics. And then lastly, we'll leave off with efficiency and equity, where we'll talk about our welfare theorems, about how markets lead us towards efficiency under certain conditions. But before we do that, in the last video, we left off talking about the welfare implications of perfectly competitive markets. And as sort of a bridge between these videos, what I want to do here is introduce a couple definitions. And this is going to help us as we work through our general equilibrium. So the main sort of high-level question is, at the heart of all of microeconomics, is how should we distribute our resources? How should we allocate our scarce resources? There are sort of an infinity of answers to this question. To sort of guide our intuition, we have some general principles. So the first one, we're going to call this the Pareto principle. The Pareto principle basically just says that a society should favor changes that help some people without hurting anyone else. So let's write this out. Society should favor changes that benefit some without hurting anyone else. So essentially what we're saying is changes are good if we can benefit some, but not at the expense of others. So can we improve some subset, holding everyone else and their welfare constant? So another sort of useful definition here is what we call a Pareto improvement. Pareto improvement. So essentially, a Pareto improvement is just doing what the Pareto principle recommends, where we benefit some without hurting anyone else. So it's sort of the movement or the improvement that the Pareto principle recommends. So let's write this out. A change in the allocation of goods. And so here we're tying it back to sort of our notion of bundles. An allocation of goods that helps some without hurting anyone else. Okay, so we've essentially just turned our Pareto principle into something we have some traction with using the models we've developed so far in this class. And we're going to take this a step further and sort of model exchanges between individuals. And we're going to come back to this Pareto improvement idea once we get there to our Edgeworth box. But before we do that, we have one more definition that's going to be helpful. And this is essentially when we reach a point where we can't find Pareto improvements. So this is what we call Pareto efficient. So Pareto efficiency is essentially just a point with no Pareto improvements. Another way of saying this is an allocation is Pareto efficient when there are no Pareto improvements, when we can't improve anyone without hurting anyone else. So there are a couple ways to write this. I'm going to write it as an allocation where we cannot improve anyone without hurting anyone else. But this is equivalent to saying there are no Pareto improvements. So let's write that out too. This is equivalent to having no Pareto improvements. Okay. So the connection here to tutorial 9, here we have some definitions of efficiency. And when we were talking about perfectly competitive markets, maximizing welfare, it turns out that this maximization of welfare is Pareto improvement. So let's write this here as a result. Perfectly competitive market. Generates an allocation that is Pareto efficient. So in this video, we're going to do something different. Up until this point, what you've seen are partial equilibrium, where we have one market. We typically have price on the vertical, quantity on the horizontal, and, a downward sloping demand curve, upward sloping supply curve. And we find a price and a quantity. But the thing is, simultaneously, there's a second market where we have prices and quantities. We have a different supply curve and a different demand curve, different prices, different quantities. So we have two markets, and they're happening simultaneously. And these prices, so let's say this is the price for Y and the price for X. These prices influence the consumer's problem. You'll remember we have our consumer's problem, which looks something along these lines, where we have two goods, let's say X and Y. We have a budget curve, a budget line, which depends on the prices. So our intercept here is our income. Let's call this expenditure, E, since we've already defined Y. So we have our expenditure divided by the price is the intercept. And down here we have our expenditure divided by the price of Y. And these prices are coming from somewhere, right? We've abstracted away from the source, the origin, and the underlying mechanisms for where these prices are coming from to this point, when we've talked about the consumer's problem, which looks something like this, where we have an indifference curve. We've intersected, or we found the tangency between the budget curve and the indifference curve, giving us, the bundle of X and Y. But somewhere underneath this budget problem, this consumer's problem, the budget is the result of a market. And to this point in the class, we haven't defined where these prices are coming from. We haven't modeled that yet. And this is what we call a partial equilibrium, where we have equilibria, which give us prices and quantities for whatever good we're looking at. But we haven't connected the markets. And this, when we say it this way, it sounds sort of silly, the fact that we haven't done this yet in all of economics, all of your economics to this point. But the reason we build up these underlying intuitions is because general equilibrium is sort of a level up in complexity. And that's what we're going to do in this video, is try to take our models of markets and consumer behavior and tie everything together. And this is what we call general equilibrium, where prices and quantities are floating across markets, and consumers are making decisions that relate to multiple markets simultaneously. And this sounds a little complicated, possibly. So the place we'll start is with a two-person general equilibrium model. So we'll call this general equilibrium. And we're going to start with two goods and two people. And this will give us our Edgeworth box. But before we get there, I want to make one last note here. Just as a general guide for where we're going at the very end of this video. Just so you can keep it in the back of your head. So first, we've talked about introducing the consumer's problem into the idea of our markets, right? And we have already talked about the fact that demand curves are coming from the consumer's problem. But when we did the consumer's problem, right, the result gave us two demand curves. We had two markets going on, which gave us two equilibria. The other side of this market is the sellers. So we not only do we have to worry about buyers and the prices resulting from multiple markets, but we also have to think about the firm side, which we've just gotten through. So one place the firms enter the picture here is with our production possibility frontier, our PPF, which in this video, I'm not going to take a deep dive into the PPF. There's a pretty good chapter, a pretty good section in chapter 10, near the end of the chapter, talking about production possibility frontiers and why they're outward shaped, why they're bowed outward. But here, before we get into our general equilibrium, I just want to make a note that this models are societal decision-making around where we are on the production possibility frontier. We have efficient allocations on the frontier, but we've never taken a stab at which one of these we should choose. And in this video, we're actually going to tie these three pieces together. Where the prices are coming from in the budgets of consumers when they make their optimal decisions. These Marshallian demands, which give us the demand curves for a market. And the fact that we have multiple markets happening simultaneously. So we have these four pieces, sort of three pieces, going on simultaneously. Two markets, one individual consumer problem, and our societal decisions around what quantities, what allocations we should choose. Okay, so that's the big picture. It seems a little daunting, possibly, but we're going to build this up from first principles, from the very basics. And in this video, we're not going to do too much practice. I'm going to save that for another video. Here, we're just introducing the concepts, as a good tutorial video should do. Okay. So to do this, we're going to set up a simple barter economy. So we're pre-prices. barter economy. So in this barter economy, we have two people, and we'll call them Andrew and Bea. So we have A and B. And we have two types of endowments, two types of goods, and we'll just call them X and Y. Keep things as simple as we can. And Andrew and Bea have some initial endowments of these two resources. So essentially we're just dropping in some endowments from the sky on sort of a desert island with only the two of them. So our initial endowments for X and Y are 80 and 50. Okay. So the way, before we set up the Edgeworth box, remember that both Andrew and Bea have preferences over two goods. And let's just draw an indifference curve that looks something like this. We could call this U bar. And some endowment going to Andrew. We'll label this YA and XA. And this is the indifference curve for Andrew. And we could set this up for Bea as well. All we're saying here is there's some indifference curve, and it looks something like this. So when we think about this problem, we need to consider both Andrew and Bea and their allocations simultaneously. So when we think about good X, we know we have 80. It must be that the allocation to Andrew plus the allocation to Bea is no greater than 80. So it must be no greater than 80. We're going to make a sort of a mathematical simplification here, and we're going to say these should be equal. And this is a simplification only in the sense that we're restricting our attention to only the allocations that don't waste anything. So as long as these goods are good, then we want to consume everything. So this is essentially just coming from the fact that more is better, and this is a result from the indifference curve, one of our primitives. And we can also do this for y. So we have YA, Andrew's endowment of A, and Bea's endowment of A. And we're just saying, let's make sure they sum to the total. Okay. So I'm going to erase this. And here's what we're going to do. So first, we're going to draw the box. Let's see if I can draw straight lines. Okay, so on the vertical axis, we will have Andrew's y. And this is going to be increasing as we move up. On the horizontal axis, we're going to have Andrew's x. And this is increasing as we move out. Now the tricky part here is setting up the endowment across these two individuals. So let's say, just as a baseline here, let's say XA YA is equal to 20, 30. And we're gonna call this point E. So on the very extreme, if we gave all of y to Andrew, this would be 8. This would be 50. And if we gave all of x to Andrew, this would be 80. So our allocation E is somewhere in between. So our x is going to be 20, which is somewhere down here. And our y is 30, which is somewhere around here. We'll plot this point. So this is our point E. And at this allocation, Andrew has some indifference curve that runs through it. So this looks something like, let's do this in blue. Looks something like this. We have an indifference curve and it runs through the allocation. Okay, so we've seen this before. This looks straight out of the consumer's problem. Now, the second part of this question relates, the second part of the setup relates to Bea. So implicit in this allocation E is Bea's side. So another way of defining this is from Bea's perspective. So we have x for Bea, y for Bea, and this is equal to what Bea is receiving, which is the total available, which is 80x, minus what's going to Andrew. So this is 60, which is 80 minus 20. And for y, we're doing the same thing, so it's 50 minus 30, so that's 20. Okay, so the trick here, and I would say part of the conceptual difficulty with Edgeworth boxes is the fact that we're defining on one graph two individuals. And the reason we can do this is because we have this relationship. So for Bea's allocation is fully defined by Andrew's allocation. So what we can do is think about this point, this extreme point, as the point where Bea gets nothing. And this extreme point as the point where Andrew gets nothing, and Bea gets everything. So instead of using two graphs, one to represent Andrew and one to represent Bea, because we have this relationship between their allocations, we can do it all on one graph. So on the horizontal, and we're going to label this on top. As we move out, as we move left on this graph, we're increasing Bea's allocation of X. And as we move down, we're increasing Bea's allocation of Y. Okay, so this is the setup. We have two individuals on the same graph, which represents the space of all possible allocations. And for the moment, we're going to abstract away from where we get 80 and 50, but we will come back to that. That's going to result from the production possibility frontier. But for now, we just need to look at these two individuals and think about how we make them as well off as possible. So let's draw Bea's indifference curve, which must run through E. And let's say it looks something like this. Okay. So this is nice. We have one allocation, we have two indifference curves, and we want to think about our Pareto improvements. Is there a way to improve both Andrew and Bea simultaneously? And this is the question of general equilibrium. So let's pick a point here. Let's call this maybe E prime. Is this going to improve both Bea and Andrew simultaneously? So for Andrew's new indifference curve runs through it. And because Andrew's moving further from his origin, Andrew is improving. So this is good for Andrew. But for Bea, this is not. So we can draw the indifference curve running through this point. And let me just maybe draw this a little better. And no, this is not further from the origin. So this point E is not improving Bea, but it is improving Andrew. Okay, so let's erase this. Let's see if we can find another point. So what about maybe a point out here? We'll call this E double prime. I will leave this here, E prime. So again, we can test the indifference curves. So Andrew's maybe looks something like this. This is not further from the origin. It's closer. So it's not good for Andrew, even though it is good for Bea. So Bea's indifference curve is increasing. Okay, so we've looked at 2 points. So we know it can't lie anywhere on the inside of either of these indifference curves. So let's maybe just shade these regions. So it can't live here because this is bad for Bea. Can't live here either. And it can't live here because that's bad for Andrew. It's below his indifference curve. So the only point, the only region that's good for both of them is here. Okay. So if let's just run through a quick little example here. So let's pick a point, call it F. We have an indifference curve for Bea and a difference curve for Andrew. And for both of them, this is better. They've both improved. Okay. So this gives us the allocation that's a Pareto improvement from our original endowment. So this is a real success. So I'm going to take a break here, and we'll come back and continue.